Okay, when you have two different trig functions in a problem, one strategy is to try to rewrite that in some way so you have one trig function. So for example, I have cosine x and sine x, and I know that sine squared plus cosine squared equals 1, or I can use the Pythagorean to rewrite. So I'm actually going to square both sides. Now when I'm squaring both sides, I am multiplying the right-hand side by sine x, and I'm multiplying the left-hand side by 1 plus cosine x. So I am possibly introducing extraneous solutions because I'm multiplying by variable expression. But we're just going to do it and see what happens. So cosine squared x plus 2 cosine x plus 1 equals sine squared x. And then sine squared x we're going to rewrite as 1 minus cosine squared x. So at this point I'm going to add cosine squared x to both sides and subtract 1. And so I have 2 cosine squared x plus 2 cosine x plus 0 equals 0. Then I can factor out 2 cosine x. Equals 0. My brain just said, well, if I introduced extraneous solutions by squaring both sides on this almost second to last step, if I divide by cosine x right now and I get rid of a solution, will I get rid of the extraneous solution or will I get rid of the real solution? So I'm not doing that. But now I have it in factored form. So I can say 2 cosine x equals 0 or cosine x equals 0. So x equals pi over 2 and 3 pi over 2. And then for cosine x equals 1, or cosine x plus 1 equals 0, cosine x is going to equal negative 1. So x equals pi. So what I need to do, since I know I squared both sides, I need to check all three of those solutions. Sine of pi over 2 is 1. Cosine of pi over 2 is 0 plus 1. So I get 1 equals 1. So pi over 2 works. 3 pi over 2, I get sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0 plus 1. So 1 does not equal negative 1. And then pi, sine of pi is 0. Cosine of pi is negative 1. Negative 1 plus 1 is 0. So my real solutions are x equals pi over 2 and pi, and not 3 pi over 2. And that extraneous happened because we squared both sides, which is okay, except that when we squared, that means we're actually multiplying both of the sides in this case by a variable expression.